Good day, this is the Professor, CBMD PhD, and today's Tuesday, October 31st, 2023. It is 2:44 and 12 seconds, AM Eastern Standard Time, and today's research, sustainable cooling. So let's jump to it here. A sustainable alternative to air conditioning, researchers set out to achieve passive cooling inside naturally conditioned buildings and hot air, arid climates. Date October 30th, 2023. Source: McGill University. As the planet gets hotter, the need for cool living environments is becoming more urgent, but air conditioning is a major contributor to global warming since units use potent greenhouse gases and lots of energy. Now, researchers have found in a new study an inexpensive, sustainable alternative to mechanical cooling with refrigerants in hot and arid climates and a way to mitigate dangerous heat waves during electricity blackouts. The researchers set out to answer how to achieve a new benchmark in passive cooling inside naturally conditioned buildings in hot climates such as Southern California. They examine the use of roof materials that radiate heat into the cold universe, even under direct sunlight, and how to combine them with temperature-driven ventilation. These cool radiator materials and coatings are often used to stop roofs overheating. The scientific investigators and researchers have also used them to improve heat rejection from chillers, but there is untapped potential for integrating them into architectural design more fully, so they can not only reject indoor heat to outer space in a passive way, but also drive regular and healthy air changes. They found they could maintain air temperatures several degrees below the prevailing ambient temperature and several degrees more below a refrigerant's gold standard for passive cooling. They did this without sacrificing healthy ventilation air changes. This was a considerable challenge considering air exchanges are a source of heating when the aim is to keep a room cooler than the exterior. The researchers hope the findings will be used to positively impact communities suffering from dangerous climate heating and heat waves. They hope that material scientists, architects, and engineers will be interested in these results, and that their work will inspire more holistic thinking for how to integrate breakthroughs in radiative cooling materials with simple but effective architectural solutions. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.